Hello everyone, I am Indumati RS, Assistant Professor in the Department of Mathematics in Maharaja Institute of Technology, Mysore. Today I am going to explain Gauss elimination and Gauss-Jordan method in linear algebra, and the subject name is Calculus and Linear Algebra. The subject code is 18 Mat 11. Now before moving to that topic, let's know about a few application parts. Gauss elimination method is usually used to understand the sequence of operations performed on the corresponding matrix. It is used to find the rank of the matrix, to calculate the determinant of a matrix, and also it is used to find the inverse of an invertible matrix. Gauss elimination and Jordan method is an algorithm used to solve the system of linear equations and also to find the inverse of a matrix. Now these linear equations are used to calculate the measurements of both solids as well as liquids. An electrical engineer uses to solve the problems using voltage, resistance and current. Linear equations are basically used to calculate age problems and distance, speed, time, geometry problems, etc. In engineering, it is used in image and signal processing, telecommunication, data mining, computational finance, bioinformatics, optimization and partial differential equation. Now let's move on to the topic Gauss elimination and Jordan method. Now what is that Gauss elimination method? How to solve the problems? Gauss elimination method means we have to reduce the coefficient matrix, that's a matrix A, into an upper triangular matrix which gives a solution by using Gauss elimination method. If we are going to reduce the coefficient matrix, that's a matrix A, into the diagonal matrix, then we will get the solution by Gauss-Jordan method. Now what is the diagonal matrix? Diagonal matrix means in a square matrix, except the principal diagonal elements, if all other elements are zeros, then it is called as diagonal matrix. Now let's solve few problems. Now see the first problem. We are supposed to solve this system of equations by using Gauss elimination method. Now the first step is the above system of equations can be written Now the first step is the above system of equations can be written in matrix form as follows. The matrix form is Ax equals B. Here A is the coefficient matrix, X is the matrix of unknowns, and here B is the constant matrix. Now write the coefficient matrix. Here the coefficient matrix is 1, 1, 1, then 1, minus 2, 3. The last equation is 2, 1, minus 1 into the matrix of unknowns. There are three unknowns, that is x, y, z equals matrix of constant is, here the matrix of constant is 9, 8, 3. Consider this as 1. Now we are supposed to consider the augmented matrix. Consider the augmented matrix, that is 1, 1, 1, 1, minus 2, 3, 2, 1, minus 1, 9, 8, 3. Now this matrix is equivalent to, write the first row as it is 1, 1, 1, 9. Now by using the row operation, we are supposed to make these two elements as 0. The operations are R2 dashes R2 minus R1, R3 dashes R3 minus 2 times R1. Now these two elements will be zeros. See the first one, R2 dashes R2 minus 2R1, minus 2 minus 1 is minus 3, again 3 minus 1 is 2, 8 minus 9 is minus 1. See the third row operation, R3 dashes R3 minus 2R1, 1 minus 2 is minus 1, minus 1 minus 2 is minus 3, and the last element is 3 minus 2 times 9, 2 times 9 is 18, 3 minus 18 is minus 15. Again this matrix is equivalent to, write the first two rows as it is, 1, 1, 1, 9, then 0, minus 3, 2, minus 1. See last one, we are supposed to make this element as 0 by using the second row of this element. Now the row operation is R3 dashes 3 times R3 minus R2. What we are doing is, we are reducing this coefficient matrix into an upper triangular matrix. Now these two elements are zeros, R3 dashes 3 times R3 minus R2, that is 3 into minus 3 is minus 9, minus 2 is minus 11, again 3 times R3 means 3 into minus 15 is minus 45, minus 45 plus 1 is minus 44. Now we have reduced this coefficient matrix, this is a coefficient matrix, we have reduced this coefficient matrix into an upper triangular matrix. Now to get the solutions of x, y, z, to get the values of x, y, z, multiply the first element by x, second element by y, third element by z, equate the to a constant matrix, that is 1 into x plus 1 into y plus 1 into z is 9. See the next one is minus 0 into x minus 3 into y plus 2 into z equals minus 1, and the last equation is here 0 into x, 0 into y minus 11 into z is minus 44. The value of z is, here the value of z is 4. We got the value of z. Substitute the value of z in the second equation, you will get minus 3y plus 2 times 4. 2 times 4 is 8 equals minus 1. Therefore, the value of y is, right, minus 3y equals minus 1 minus 8, that is minus 9. Therefore, the value of y will be 3. Now, we got the values of y and z. Substitute the values of y and z in the first equation, you will get x plus the value of y is 3 plus z is 4, 3 plus 4 is 7 equals 9. Therefore, the value of x is 9 minus 7 is equal to 2. Therefore, the solution is x equals 2, y equals 3 and z equals 4. What we have done is, we have reduced the coefficient matrix into an upper triangular matrix, then we will get the values of x, y, z. This is by using Gauss elimination method. Now let us solve the same problem by using the another method, that is Gauss-Jordan method. We are supposed to solve this system of equations by using Gauss-Jordan method. Now in the solution, write the above system of equations can be written in matrix form, that is Ax equals B. Here A is the coefficient matrix, X is the matrix of unknowns and B is the constant matrix. Consider the augmented matrix. Now here we are supposed to reduce the coefficient matrix into the diagonal matrix. Diagonal matrix means except the diagonal elements, all other elements should be 0. We are supposed to use only the row operations. Now this matrix is equivalent to, write the first row as it is. Now use the row operation, make these two elements as 0. The row operation will be R2 dashes R2 minus R1 and then R3 dashes R3 minus 2 times R1. These two elements are 0. Now what is the row operation? R2 dash will be R2 minus R1. Minus 2 minus 1 is minus 3. 3 minus 1 is 2. Again 8 minus 9 is minus 1. See the third row operation, R3 dashes R3 minus 2 times R1. 1 minus 2 times 1. R3 dashes R3 minus 2 times R1, that is 1 minus 2 times 1 is, we will get minus 1. Minus 1 minus 2 is minus 3. Again 3 minus 18 is, 3 minus 18 will be minus 15. Now this matrix is equivalent to, write the middle row as it is. The middle row is 0, minus 3, 2, minus 1. Now we are supposed to make these two elements as 0 by using this element. The row operation will be R1 dashes 3 times R1 plus R2, that is 3 times 1 minus 3 will be 0. R3 dashes 3 times R3 minus R2, that is 3 into minus 1 is minus 3, minus of minus 3 will be plus 3, the value will be 0. Now these two values are zeros. Now see the first row operation, R1 dashes 3 times R1 plus R2, that is 3 times 1 plus 0, you will get 3. 3 times R1, that is 3 into 1 plus 2, you will get 5. 3 times R1 means 3 into 9 is 27, 27 minus 1 is, you will get 26. See the third row operation, R3 dash will be 3 times R3 minus R2. 3 times R3 means 3 into 0 minus 0 will be 0. 3 into minus 3 is minus 9. Minus 9 minus 2 is minus 11. 3 into R3, that is 3 into minus 15 plus 1, you will get minus 44. Again this matrix is equivalent to, write the last row as it is. What is the last row? 0, 0, minus 11, minus 44. Now here we are supposed to make these two elements as 0 by using this element. The row operation will be R1 dashes 11 R1 plus 5 R3. Then R2 dash will be 11 R2 plus 2 times R3. Now these two elements are 0. Now see the row operation, R1 dashes 11 R1 plus 5 R3. 11 times 3 plus 5 times 0. 11 into 3 is, you will get 33. 11 times 0 plus 5 times 0, you will get 0. The next is 11 times 26 plus 5 times minus 44 will be equal to 66. See the next row operation, R2 dashes 11 R2 plus 2 R3. 11 R2 means 11 into minus 3 is minus 33. Okay, see the first one, 11 R2 plus 2 R3, that is 0. The first element is 0. 11 R2 means 11 into minus 3 plus 2 times 0, you will get minus 33. See the last element, 11 times R2, that is 11 into minus 1 plus 2 times minus 44, you will get minus 99. Now we have reduced the coefficient matrix, this is the coefficient matrix. We have reduced the coefficient matrix into the diagonal matrix. Now to write the solution, multiply the first element by x, second by y, the third element by z, equate the two a constant matrix. You will get 33x, the remaining terms are 0, equating the two constant matrix, you will get 66. See the next one, 0 into x minus 33 into y is equal to, again this element is 0, the constant matrix is minus 99. See the last row, that is 0 into x, 0 into y minus 11 into z is equal to minus 44. The value of z is the value of z is 4. Here the value of x is 2 and the value of y is 3. Now the solution using Gauss-Jordan method is the value of x is 2, y is 3 and z is 4. Now see the next problem, we are going to solve this system of equations by using Gauss elimination method. The first step is write the above system of equations can be written in matrix form as Ax equals B. Write the coefficient matrix. The coefficient matrix is 2, 1, 3, 4, 4, 7, 2, 5, 9. Matrix of unknown is, there are 3 unknowns, x, y, z equals matrix of constant is 1, 1, 3. Consider this matrix as 1. Now we are supposed to consider the augmented matrix. Right, this is equivalent to, here the augmented matrix is 2, 1, 3, 1, 4, 4, 7, 1, 2, 5, 9, 3. Consider the augmented matrix. Now this matrix is equivalent to, writing the first row as it is 2, 1, 3, 1. We have to make these two elements as 0 by using this element. Apply only row operation. R2 dash is R2 minus 2 times R1. R3 dash will be R3 minus R1. These two elements are 0. R2 dash is R2 minus 2 times R1. 4 minus 2 times 1 is, we will get 2. Again 7 minus 2 times 3. 2 times 3 will be 6. 7 minus 6 is 1. 1 minus 2 times 1, that is minus 1. See the last row, R3 dash is R3 minus R1. That is 5 minus 1 is 4. 9 minus 3 is 6. 3 minus 1 is equal to 2. Now write this matrix is equivalent to, writing the first 2 rows as it is 2, 1, 3, 1. The second row is 0, 2, 1, minus 1, 0. Now we are supposed to make this element as 0 by using this element. The row operation is R3 dash is R3 minus 2 times R2. That is 4 minus 2 times 2 will be 4. That is 4 minus 4 will be 0. This element is 0. 6 minus 2 times 1 is equal to 4. And the last one is 2 minus 2 times minus 1 will be plus 4. Now we have reduced the coefficient matrix into an upper triangular matrix. Now to get the required solution, multiply this term by x, this term by y, this term by z, equate that to a constant matrix. Now you will get 2x plus y plus 3z equals 1. See the next one, 2y plus z equals minus 1. The last one is 4 times z equals 4. 4z equals 4 means you will get the value of z as equal to 1. Now substitute the value of z in the second equation, that is 2y plus the value of z is 1 equals minus 1. 2y is equal to minus 1 is minus 2. Therefore the value of y is equal to minus 1. Now we got both y as well as z values. Substitute these values in the first equation, you will get 2x minus 1 plus 3 times 1, that is equal to 1. Therefore, 2x minus 3 plus 1 will be, minus 1 plus 3 is equal to 2. 1 minus 2 is minus 1. Therefore, the value of x is minus 1 by 2. Now, the solution is the value of x is minus 1 by 2, y is minus 1 and z is equal to 1. Now, let us solve the same problem by using Gauss-Jordan method. We have to solve this system of equations by using Gauss-Jordan method. In the solution, write the given system of equations in matrix form, that is Ax equals b. Consider an augmented matrix. Now, this matrix is equivalent to, writing the first row as it is 2 1 3 1. Now, using the row operation, make these two elements as 0. The row operation will be R2 dashes R2 minus 2 times R1, R3 dash will be R3 minus R2, R3 minus R1. Now, these two elements are 0. The row operation is R2 dashes R2 minus 2 times R1, that is 4 minus 2 times 1 is, we will get 4 minus 2 is 2. 7 minus 2 times 3 is 6, 7 minus 6 is equal to 1. 1 minus 2 times 1 is minus 1. See the third row operation, R3 dashes R3 minus R1, 5 minus 1 is 4, 9 minus 3 is 6, again 3 minus 1 is, 3 minus 1 is equal to 2. Now, write this matrix is equivalent to, write the middle row as it is, the middle row is 0, 2, 1, minus 1. I have written the middle row as it is. Now, by using the row operation, make these two elements as 0. The row operation is R1 dash is 2 times R1 minus R2, then R3 dash is R3 minus 2 times R2. Now, these two elements are 0. See the row operation, R1 dash is 2 times R1 minus R2, that is 2 times R1 means 2 into 4 minus 0, 4 minus 0 is, you will get 4. 2 times R1, that is 2 times 3 means you will get 6, 6 minus R2, that is 6 minus 1, 6 minus 1 is equal to 5. 2 times R1, that is 2 into 1 minus R2, that is minus of minus 1 is plus 1, 2 plus 1 is equal to 3. See the last row operation, R3 dashes R3 minus 2 times R2, that is 0 minus 2 times 0 will be, you will get 0. Again 6 minus 2 times 1, 6 minus 2 is 4, and the last one is 2 minus of 2 into minus 1, again you will get 4. Now, this matrix is equivalent to, write the last row as it is 0, 0, 4, 4. Now, the row operation is R1 dash is 4 times R1 minus 5 times R3, then R2 dash will be 4 times R2 minus R3. Now, these two elements are 0. See the row operation, R1 dash is 4 times R1 minus 5 times R3. 4 into 4 is 16, okay, 16 times, okay, 16 minus 5 times 0, you will get 16. 4 times R1 minus 5 times R3. This element is 0. See the last element, 4 times R1 means 4 into 3 is 12 minus 5 times R3, that is minus 5 into 4 is 20. 12 minus 20 will be minus 8. See the next row operation, R2 dash is 4 times R2 minus R3. 4 times R2 means 4 into 2, now this will be 0. 4 into 2, that is 8 minus 0, you will get 8 only. 4 times R2, that is minus 4 into minus 1, minus 4 will be minus 8. Now we have reduced the coefficient matrix, this is a matrix A, into the diagonal matrix. Now we are supposed to write the solution, that is 16x is equal to, the constant matrix is minus 8. See the second row, 0 into x plus 8 into y is equal to minus 8, and the last one is 4 times z is equal to 4. The value of x is minus 8 by 16 means you will get 1 by 2. The value of y is minus 1 and the value of z is 1. This is the solution by using Gauss-Jordan method.